Welcome everybody. In this video, we're going to take a look at how Entity Framework core queries work. So from writing your link statement to actually being translated to SQL, to then perhaps how does Entity Framework translate it to each individual provider. This is going to be an advanced video, so I'm assuming you already know a couple of things like Entity Framework or Entity Framework core. You're familiar with the concept of reflection and code as data, as well as the expression API. You don't need to know all of it, but at least some of the expression API. Finally, we are going to be looking at Entity Framework source code. I'm going to try to be as slow or as descriptive as possible, but if you are uncomfortable with reading other people's source code, you might struggle a little bit. Nevertheless, we got quite a bit to cover, so let's get started. So Entity Framework core, the main thing that you work with is the DB set. This is where you start. You say .where, .select, .toList, and you have your entities. The DB set specifically hides behind the IQueryable interface, and the interesting thing about the DB set is that the implementation of the DB set doesn't exist until the runtime. That means that I'm gonna have trouble showing you what is actually there under the hood if I don't have a running application. For this reason, we are going to take Entity Framework core and we're just gonna throw it out the window. We're gonna forget about it and that it even exists. And we're just going to take a look at the IQueryable interface because what it has is an interesting property called expression. It's essentially a history or the expression that represents the current query that you've built up. If you've used the INumerable interface, you know that it is not an actual execution on your list. It is an immutable thing where you are slowly building up your query, where at the end you call toList or whatever method that forces enumeration. With IQueryable, you actually get that information of your built up query in this expression. I'm going to be showing my examples in LinkPad because it has a very nice visualization feature, the dump method. I know some people are alarmed when they see it. They don't know what it is. Don't worry, sit back, relax, grab a cup of tea and enjoy. So enumerable query, we assign it to the IQueryable string. Again, we just have a very simple data source, just a list string. But the important thing here is that enumerable query implements the IQueryable interface and we get access to the expression. And then we can dump it and we see something like this. So this may look like a typical object, although people that work with expressions, they will know it's a constant expression, it's a node type constant. It's essentially a thing that evaluates to a constant value. And the code that represents this constant value at runtime is now captured as data. So we can write a little bit more code to actually evaluate this expression and turn it into an actual value. At the moment, it's just information about the value that it represents. But anyway, that is more on the topic of expressions rather than Entity Framework and how it works. So again, back to the IQueryable, we're going to try to use this query as we use Entity Framework. So here's a very standard operation. We got our Q1, which is the DB set, and then we're just calling where in it. So we're starting to build up the query. And we want to actually see what the expression is when we build it up. So here I'm going to dump out version 2 and version 1 so you can actually see the differences between them. Now with version 2, this turns into an argument provider, which is a node type of call. So it is essentially a method where first we have the constant value on which we then perform this operation. Now we're going to take it a little bit further. We're going to extend this query. I'm going to run this again and I will zoom out a little bit here, but it's just important to see the shape of this query. We still have the constant value. We still have the original where we're filtering by the A, and then we have the next where clause where we're filtering by the B. Now let's add one final piece to our query. Here we're going to have a projection. So if we run this, so we still have the constant value right over here, the original first where, the second where, and now wrapping all of it, the select. If you have not yet realized or you're not familiar with this structure, it's essentially a binary tree. The expression that is being built up is a binary tree, which starts with the method call expression. So this node type right here. We're now at a point where we can say, okay, So we have this DB set, we're putting these link statements on it, and we can see that, okay, the DB set is capturing information around if I'm calling where, if I'm calling include, do I call select, and it is actually capturing the information about what is the actual expression or the lambda function that I'm using inside of those method calls. How can it actually take all of this data and then transform it into SQL? Nevertheless, different providers. For this, we'll actually need to crawl or traverse this tree, and you use something called an expression visitor to do this. Let me remove all the dump methods. So we retain the query, however, the output is going to be empty. So now I can actually illustrate things a little bit more. And this is what an expression visitor looks like. All I have to do is call into this expression visitor, and then it has a bunch of functions which I can overload in order to look or modify an expression in one way or another. But essentially, this gives me the ability to traverse the expression tree in any way that I want. What I can do is I can either press F12 to bring up ILSpy to take a look at the members of the expression visitor in Visual Studio. If you have decompilation, you can do that as well. If you don't have any of that, you can use the F1 keyword, which is going to Google search it for you, or actually open the documentation where you can go to the methods and you can try to find the method that you want to override. Specifically, by the node type, you can identify what kind of node type it is. I know it is a method call, so visit method call is the thing that I want to override. So here I'm overriding the visit method call method of my visitor, and if I run it, nothing's gonna happen. What I actually need to do is take the expression and put it into my visitor. So my expression visitor, and then we are going to visit and specifically grab the expression, and if we are visiting or allowing to visit a specific expression that is being here, which the root one is the method call, so we're going to see method call being called a couple of times because there's a couple of method calls. But as we're traversing the expression, we get the option to return an expression as well. So here I'm just doing the default behavior. Let us just pass through it, inspect it with the dump, and return the same value. Potentially what you could do is you could go to the node, you could call update, and then you have the option to update the expression. So you basically, as you're traversing the expression, let's say we're on this where expression and we're looking at this lambda function, we can say visit lambda function, and once we're at the lambda function, let's update the lambda function to not have variable x or to not have variable b, but rather have variable c. So we have the power to update the expression in that way. How you do it is a topic for another video. Just understand that it's something that you can do. You can not only read the code as data, you can also update that data. And that is what Entity Framework Core does. It records the method calls that you use for your query and whatever expressions you supply into those method calls. It reads them, it extracts information, and then it updates them. The update method will spit out new expressions, so it's not like you're mutating something. You're constantly creating new expressions as you update them. We'll now move into a different linkpad script. Feel free to pause to familiarize with it, but we have a typical Entity Framework Core entity that you're going to register with the DB set, and now we're taking a look at the select statement from the IQueryable interface. This is essentially its signature. This is the parameter that is going to accept. So if we take a look at this select expression and we just dump it, and rather it's the selector, we're going to see all that familiar information, familiar as it can get, just information about your code. We have this expression right here. We can see A in here, we can see the ID and the name, we can see information about what code we have written, but rather at runtime. We now want to go ahead and work up an example where we can take a look at this information and we can turn it into SQL. So we'll go for a little development process where I'm seeing that the node type of the overall thing is a lambda. So in my visitor, that is what I want to override. I'm going to open up ILSpy and I'm going to find the visit lambda method because there are no override helpers here. So I'm just going to do something like this, override, and at the end base visit lambda and pass the node. Now I can stop dumping this, put it into my visitor, and actually dump the node at this point. So here I have the visitor, I'm just visiting my selector and I'm dumping it right here. So let's go ahead and as always, forget my semicolons. But here we have it. So this is the lambda. I have the tag lambda here just so you know where we are printing it from our visitor. And now we want to start to slowly extract the information. We have the body parameter here. If we take a look at the node and then body, we're going to see that it's just a basic expression. It's the abstract expression. It's not a concrete expression. So if I collapse this, I will see that the body itself is a new expression. So if I'm gonna go ahead and force a visit of the body right here, so I'll say node body and force the body visit, I will need it to visit the new expression. So here you can see me overriding the visit new expression method. If I run this, we're gonna see the new call being outputted here, the lambda. And we're basically visiting one too many times. We're visiting the body node here. We're visiting the body node once we revisit or recall the base visit lambda method. It will automatically try to traverse the whole tree. So we don't really need to call this visit here, but it allows us to control at which points we want to do what. Nevertheless, the point is now that I have access to the new expression here, to the node, I have access to arguments and members, and I can start to build up my SQL query string essentially. So what I'm going to do is I'm going to pass in a string builder to this SQL expression visitor, and I'm just going to, well, accumulate the string in the correct places as I'm traversing this expression, and slowly but surely I'm going to get my SQL statement. First I'll force the lambda visit so I can do things before and after. I'm now defining a string builder and passing it into the visitor and, well, accepting it into the constructor. I'm going to start with select, and then once I visit this new node, I'm going to know what actual members I'm selecting and from what entity. Again, all of this information is available to me. I can see the members, ID and name. And then with regards to where from I'm selecting, I can see on the lambda I have the type entity. So, I can make out the entity name from that type right there, or perhaps the parameters. Here I iterate over all the members and, well, I append them to the string, nothing too crazy, and I will just remove the excess comma space after I'm done with this. Finally, after the lambda, this is where I want to say from whatever table, and I can reach this on the first parameter, which is going to be entity. Again, it's a select statement, I know the first parameter is always going to be some kind of entity type that I'm trying to project from. If not, I write additional logic to handle those situations. But I just grab the name here, and finally let's just go ahead and place a semicolon for correctness. I don't even know if it's correctness, but anyway, let's go ahead and run this and actually return this. So we build this at the end, and I'm just going to clear the other dumps so it's a little bit neater. So after clearing the dumps, let's go ahead and run, and this is what we get. So select ID name from entity. We're able to traverse this expression and create SQL on the back of it. Now the big question is, this looks rather primitive, and it is. Does Entity Framework Core do the same? Partially, yes. It does similar things, but in different places for specific reasons. I'm going to zoom out a little bit here because we kind of know the code details, but I'm going to point to places, and as long as you kind of know design patterns and how to decouple things, you're going to understand what I'm going to say next and why the decisions that Entity Framework Core team and whoever created it made, and yeah, why the basically stuff makes sense. This visitor that we're looking at here, it's going to be covering different things that it can visit. This is the Entity Framework interface. This is the contract under which Entity Framework operates. So this is the first abstraction layer. This is the thing that you don't want to change. So in your code, this is what you're going to have. This is how you define queries. The promise is then that you can potentially translate it into different providers. So there are things that sit in these methods and things that get injected into the implementation of this contract that will basically adapt that implementation to different providers. So first thing that you have is you have this contract, and it's the base contract. As you have different providers, so for example SQLite or SQL Server or PostgreSQL, they can extend the contract. They can give you additional methods on the entity framework contract to basically say, all right, you call these additional methods, we're going to perform these provider specific things. That is around building up the initial layer of the query. This is its initial representation. What entity framework does, it doesn't go ahead and start accumulating the expressions into a query first. First, what it does is it takes this query and it transforms it into this intermediate object. And these are SQL expressions. These are meant to represent the actual SQL syntax for each provider. So let's say if a statement of SQL looks different between the two providers, you have this base intermediate object, this base SQL statement, how it looks like, and then each individual provider can override a class and supply that different implementation. So when you're using that provider, this intermediate object is going to have a slightly different implementation, so it's going to resolve to slightly different SQL statements. So let's go ahead, open the hood, and take a look at some of the source code, so perhaps the things that I've just said, so they make a little bit more sense. In this LinkPad script, we have a very simple setup for Entity Framework where we're using an SQLite provider. We are performing a where and a select just so you can see what's happening under the hood, but what is actually going to happen? I'm going to run this script, I'm going to have a delay here, and then I'm going to have a writer here where I have the solution for Entity Framework. I'm going to go ahead and attach the debugger to this process over here. So let's run this. Process is 11,000 something. I'm going to attach it here, and now we wait. So I have breakpoints sprinkled over the code base, and I'm just going to narrate things as they're happening. So currently we're in the query compilation context. This is essentially after we have written our dbset.where.select, and as we say .toList, we say, okay, new query compilation context, put the expression into there, and that is basically our segregated unit of we are compiling the query here. This is where bulk of the work happens. This is how we organize code. So bulk of the work happens in this class where first we have the preprocessor and then post-processor factories. I'm just going to get these out of the way because they do things like validation, null checks, etc., optimization, you know, the padding that you would usually have to do for your applications. The interesting thing that we're after actually happens on line 189. We take our originally written expression and we put it into the contract. After this, we will end up with this intermediate object. Again, the beauty about the intermediate object is that not only can this expression go through this process and end up at this intermediate object state and the rest of this still work, we can take any other process as long as it can end up in this intermediate object step. The rest of the translations to all those different providers can still happen. Now let's take a quick look at the query, and this should look a little bit familiar where this is our node type call. We have, you know, the base query root expression with the where, and then we have the contains. And as we would stack our expression, the arguments array here would grow. And again, it would just be a binary tree. So this is the original thing that we receive. Let's go ahead and step into the actual translation process. So after a bit of plumbing, where we arrive is relational SQL translation expression visitor. Okay, so we have this initial expression. Again, we're putting it into the translator. The translator knows how to visit the whole expression, and on the back of it, it will spit out this intermediate object. So let's go ahead and step through this. You will have a bunch of if statements that are gonna check, specifically here we're checking, is this a contains method? Are we trying to perform a contains operation? So it's just gonna get the stuff from different places and it's gonna arrange it into correct places where you'd expect it in correct format on this intermediate object. So we will step through this, and here we have the contains translator. The class itself isn't so interesting. The important bit is the translator concept, and I'm going to refer to it a little bit later. This is essentially the contract. Remember that you can extend the contract. The presence of the contains translator means that you are allowed to use .contains when you're writing your where statement. If the contains translator wouldn't exist, you would not be able to say x.contains and whatever parameters. So this is the first one, and then we create this in expression, which is essentially the end result that is going to go into the intermediate object. We then visit some more. We encounter this second contains expression, and again we go through the contains translator, and again on the end of it we end up with another in expression object. So past all of that, we are now holding our intermediate object, and the intermediate object is not done at this point yet. This step is also very interesting. What happens is the query actually contains of two parts. The first part is the generation of the actual SQL, and the second bit, what is referred to as the materializer, and you can say it says here inject tracking. Basically the materializer, if I can say it correctly this time, this is the thing which reads the result from the SQL server and actually creates actual objects, actual entities on the back of it. And if it needs to do change tracking, this is where this happens. So that is a topic on its own. We're going to be skipping this because this is already quite a loaded example. The other bits don't matter. We create this query one time. Parts of it that we can cache, we cache. The things that we can't cache, we don't cache. And we're going to see an example of this. So we get past compile and let the rest of this method run. What we're going to see now is the in expression getting triggered again. This is the bit that cannot get cached. The reason it cannot get cached is because names is a parameter. We cache the shape of the expression, however, not the parameter. So you can have the same shape and only the one bit of it is going to change. So next time I might supply a different array. However, it will not need to go and reconstruct the whole query. It just needs to change that one little segment. So this is why you see this in expression being recreated again. And the same is true for the other expression as well. So I pressed F5 there once, if you've seen it like a little bit, but yeah, basically we run through this. This part should look familiar. This is essentially the select expression here is the intermediate object, and just so you can see the convenience of it, here you can see where do we have the group bys, do we have different flags, are we trying to order this? Here's the projection, so the things how you would build up the select, and then we have the predicate, so it's the where statement, and if we have nested subqueries, well, you just have the same select expression. So it's infinite composability. I don't know if Entity Framework like fully actually supports that, but it looks like it does. But this is the intermediate object. You can write a million queries, right? 100 different queries, all different representations. They will eventually, through the translation process, through the contract, boil down to this same select expression with different populated variables, which can then be reliably always parsed into an actual SQL query. So let's go through this magic with this relational command builder. I'm going to pull this up here. We're going to go into this relational command builder. Hopefully you can see this command text builder. This is what I want you to pay attention to. We're slowly going to see it build up as you go through this process. So select. Here we go for the projection. If you think about what the projection is, you will be able to predict what is going to be appended here. I put another breakpoint here. We're visiting the in clause generation. So if it finds the in expression, it knows how to translate it specifically. And pay attention where in the SQL generator. This is also going to be relevant. I'm going to show you how other databases may adapt from this intermediate object onto their own provider. We read things from the in expression, and depending on the information which it contains, we generate the correct SQL syntax, right? So we are gonna step list, and here we're gonna see select, C, and name, basically the projection being appended to the command text builder. The rest of this method is more the same. So the bit right here where the where clause, this is the part where we run past it. We look at the predicate, part of the intermediate object, and that will contain the condition that we should generate. So I'm going to put a breakpoint here. Again, we're going to go past this in, and I'm going to hit this breakpoint, and you can see basically at the end it is a string builder. And I'm going to run through the rest of it and detach the debugger. So again, quickly to recap, we get the original expression. It comes in through the contract into the intermediate object, and then the query SQL generator always knows how to traverse the intermediate object and always generate SQL on the back of that. Now, the two bits you hopefully remembered was the translator and the query SQL generator. So the translator, as I explained previously, it is a way to extend the contract. Here we're going to take a look at source code of PostgreSQL provider. Here we have the new GUID translator. So this is PostgreSQL allowing you to extend the syntax. It allows you to use GUID, new GUID, when you're doing your select or when you're doing your where. Otherwise, if another provider doesn't support it, that contract is broken, right? That contract extends only to work with PostgreSQL. And likewise, if we try to find SQL Server new GUID, so this is actually in the repository, the SQL Server, Microsoft SQL Server, it's gonna have, you know, a slightly different syntax, but the premise is the same. We look for this syntax in the original written expression, and if that syntax is supported, if we want to support new syntax, you have to go and write one of these translators. Then for the other part, once we have our intermediate object and the query SQL generator is looking at the intermediate object to translate it into SQL, for NPG-SQL, for example, what it will do is, again, let's take a look at this query SQL generator overriding the original query SQL generator. And the interesting part is here, so the get operator. If we take the method name and we take a look at it in the original query SQL generator, so I'm going to search for it right here. Let's jump into there, and it's going to go off the operator map. Here, the point of interest is this add operator, the plus, right? So PostgreSQL says when you're using the plus operator and you're actually working with strings, you want to do concatenation, and specifically for PostgreSQL, we are going to translate that to different SQL. We're going to use the special pipe operator. And again, I'm reminding, this happens at the stage when we're actually translating from the intermediate object into actual SQL. So it doesn't matter what I've written at the contract stage. I might have written double plus. So as long as my provider managed to coerce that double plus into this intermediate object, which then holds this expression type of add, PostgreSQL knows how to adapt that to its own style of string concatenation. And that is pretty much it. So by saying it, obviously there is a lot more to the entity framework than what I've covered today, but hopefully I highlighted an important concept for you, that where you can have many contracts going into this intermediate object, where on the other side you can then adapt it in familiar ways. You know, kind of like CLR, where you have F#, C#, VB, the common language runtime, and then it can go on Linux, Mac OS, or Windows. This will be it for this video. Thank you very much for watching. Hopefully you've made it all the way through, learned a lot of things, and maybe have some questions. So leave them in the comment section. Don't forget to like, subscribe. Big shout out and big thank you to all of my patrons who are choosing to support me. It really helps out a lot. If you're not supporting me, please consider. Don't forget to check out the links in the description. Stay healthy out there, and see you in my other videos.